Hey guys, sorry for the delay. Everything is sorted out now, but I had some issues with the Firefox plugin, with the Hangouts plugin. But yeah, a quick restart sorted everything out. All right, so welcome to the Advanced API Discoverability workshop. So this is going to be a deep dive into API discoverability. This is essentially going to be first starting out with some foundational technical concepts, but then we're going to move into some really more advanced and practical implementation aspects. And of course, we are going to go over some of the basics, but this is an advanced API discoverability training. So some assumptions are made. I made some assumptions about the level of just API understanding. So let's go quickly over the basics and let's get to the interesting scenarios. So my name is Eugene. I have a lot of APIs implementations kind of under my belt, probably over 150 now, and some of them actually got hypermedia right. I'm happy to say that now, but of course in the early days, hypermedia was not at the forefront of of my goals when I was implementing an API. So that meant that a lot of them did not get hypermedia right. So anyway, that has been kind of the early days of hypermedia. Now, the goal of this workshop, the goal is basically to go over the foundations of API discoverability, understand how important those foundations are and how important discoverability is for the clients of your APIs, and then go over implementation scenarios. So go over really more of the advanced scenarios with Spring and with Spring HATEOAS. That is the goal. Now, on the agenda, we are going to start talking about REST, and we are going to lay the groundwork, and we are then, of course, going to talk about HATEOAS. We are going to talk about why does it pay off to build a discoverable API, why does it make sense to build that, and how does that really help the client? Because at the end of the day, that's what we care about. We care about helping the client consume the API, and we care about their experience. And ultimately, when we look for creating a flexible implementation that will allow us to change and to evolve the API, ultimately what we care about is we care about not disrupting the client. We care about making non-breaking changes, and we care about finding techniques to make those breaking changes non-breaking. So ultimately, the API is all about the client experience. Now, we are going to briefly look at how to do this manually. Doing it manually is certainly an option. You can do it manually with Spring, okay. The only problem with doing it manually is that it just takes a lot of code. It's verbose, it's not clean, so obviously we are not going to do it manually, but we are going to look at a few implementations that allow you to do it manually, because there are cases where you have to do it manually. So for example, let's say that you are not able to add Spring HATEOAS to your project. There are many reasons for that, but basically you're not able to do that. That's fine. There are still manual ways to implement HATEOAS. They're just more verbose. We are then, of course, going to talk about leveraging Spring HATEOAS. So that's going to be the bulk of the implementation that we do, leveraging Spring HATEOAS and implementing some interesting scenarios with it. Now, let's start talking about REST. Let's start with the basics. So REST itself is an architectural style, and it's essentially a set of constraints that basically end up with a architecture that resembles the web. And that's, of course, no coincidence. Roy Fielding, when he wrote his doctoral dissertation, had the web as a mirror. He looked at the web architecture and he wrote the RESTful approach to mirror the web architecture. So that's no coincidence. And basically, REST is just a set of constraints, right? So it's a set of architectural constraints, It is certainly not the only way to develop a system, but it's definitely a good way. And it's a good way because it models a very proven and very well-known architecture, which is at the end of the day, it's the web architecture. So of course, the scalability of such a system has been proven in practice, and it makes for a good set of constraints. However, it's important to understand those constraints well because they, of course, do not match each and every system. They match some systems. Now, we are only going to talk about the uniform contract constraint. And the reason we care about this one in particular is that this one leads to HATEOAS, right? This one, HATEOAS is essentially a part of this constraint. Now, at a very high level, this constraint says that the service and the clients must share a single interface. They must share a single uniform technical interface. And what that means more practically is that you never build an API for a specific client. You never build an API for, let's say a mobile client, and then you build another API for the desktop client, and you never do that. So all clients, regardless of what these are, and of course, in this day and age, clients are very, very, wide-ranging and very varied. Like we have a lot of clients, we have mobile, we have desktop, we have, a lot of in between, a lot of JavaScript heavy applications. We may have, just a lot of potential clients. For example, a smartwatch can be a client. This is a new form factor. So a lot of clients, and we can never really know what clients are going to use our API. So that's definitely something that a uniform technical interface, a uniform API helps a lot there. Because at the end of the day, we don't have to know. As long as we build a solid API, we don't need to know what are going to be the clients, like the exact details of the clients that consume that API. So that's why this uniform constraint really helps, especially today. This wasn't necessarily the case, 10, 15 years ago, but it's certainly the case now with the mobile track moving so fast. So as I was saying, this uniform interface needs to be reusable. It needs to be reusable by a wide range of clients and over a wide range of interactions. So we never know how those clients are going to necessarily interact. Like the technical details, we're going to get new clients consuming our API, and that should be perfectly fine. Now, what that means is that the API needs to provide, of course, generic and abstract capabilities. So it cannot provide very specific capabilities for a single client. It needs to keep the API operations very generic and very abstract so that it's never fixed to that single client. Now, what about HATEOAS? HATEOAS, first of all, stands for Hypermedia as the Engine of Application State, which is a terrible acronym, of course, but there we have it. And just as a quick side note, it's pronounced either HATEOAS, and I also heard it pronounced HATEOAS. I don't think there's any reference pronunciation, so you can pick and choose whichever way you like. Now, this is part of the uniform contract constraint in REST. This is why we started with the uniform contract constraint, because HATEOAS is part of that. Now, in theory, and I do stress the in theory part, the API should have no out-of-band information. So what that means is essentially there should be no reason we have to document an API. So theoretically, you could have an API that has literally no documentation, right? Like as a web page doesn't have any documentation, and you consume that web page by just consuming it, by basically navigating the system, and you're being directed through that. The API should be the same way. However, that is the theory. In practice, we are not yet there. We are lacking some of the standardization around making that happen. we're lacking the standardization in terms of media types, right? HTML is a good standard. It's the only standard. However, on the RESTful side of things, we don't have such a ubiquitous standard. So HTML is, unparalleled in the REST, let's say, media types world. We don't have a corresponding dominant standard. We also don't have a lot of rel types, a lot of standardized relation types. And we're going to get to that in a second. But the point being, we are not there yet in terms of standardization. We may get there at some point when, one of the media types that is competing right now will get the upper hand and will gain the traction that it needs to. But for the time being, we are not yet there. So the idea here is that since we're not yet there, that doesn't mean that it's an all or nothing approach. We can still get a lot out of HATEOAS. We can still put, a lot of use behind HATEOAS, even if we're not yet at the point where we can create an API with literally no documentation. We are not yet at that point, but HATEOAS can still provide a lot of benefits from the point of view of evolving the API, creating an entire class of changes that without HATEOAS are breaking changes. So as soon as you make one of those changes, you're making a breaking change and you're breaking existing clients. Well, that class of changes can become backwards compatible. This is one of the major strategies of keeping changes backwards compatible and keeping changes essentially not breaking. If you make the change to the API, you do not break existing clients, which of course is a critical thing because breaking existing clients is a lot of work. All right, let's start with a practical example. Let's start just with a scenario where you are basically buying a book from Amazon. So what is that scenario? How does that work? What does that look like? Well, let's go for it. So the first thing you do is you find the ISBN, right? The identifier of that book. That's the first thing. You then go to the Amazon documentation and you find the book URL pattern, right? You try to find the pattern to get to the book, right? To get to the URL of that book. You then use the ISBN with that pattern and you get the URL. You do a get on that URL and you basically get the book JSON. You then go back to the documentation, you look for the add to cart operation because you're aiming to buy the book, right? So you want to add that book to the cart and then you want to buy it. So you do a post, you trigger that process of buying the book, of adding that book to the cart. You then go back to the documentation, you look for the buy operation. Now that the book is in the cart, you want to buy the cart. And that's it. That's basically how you buy a book from Amazon. Not quite, not quite, definitely no. This is not how we use the web, okay? That experience, the experience that I have just described is actually usually the experience of, for example, buying a book through an API. But if this were how we use the web, nobody would do it. That would be crazy. We would not buy books from Amazon ever if we had to go through that process. Yet, that is the process that a client of an API that does not use HATEOAS, that's the process that they go through. That is basically what they have to do. They have to go to the documentation for each and every operation. They have to figure it out. They have to go back, form the URL pattern, create the operation, go back to it's a whole process. So we don't want that. Now, how do we actually buy a book from Amazon? Well, we navigate to the book page, we click on a link, and that link will add the book to the cart. We then click on another link and go to the cart, and we click on another link to buy. That's much simpler. That is much more palatable. You can actually go through that process in a few seconds, and you can actually buy the book without documentation, without any other interaction. You just click on a few links and you bought the book. So what was the common thread here? What was the common thread through the way that we actually buy the book? Well, it's the links. The links were the driver. The links were the common thread that allowed us to go from point A to point B to point C to being done. That is basically the driver. And so that's what we care about. We care about the links. So simply put, hypermedia means including links in your responses. That's a very simple definition, but it's very, very close to the practical truth, right? That is what hypermedia means. Now, a quick quote here, a quote that I found, a little bit more theoretical. Hypermedia types are media types that contain native, and native is the important part here, native hyperlinking semantics that induce application flow. So why do we care about native? Well, we care about native because we want things standardized. And we want things standardized because if we have standardization, then we can build clients around that standardization and around those assumptions. That's why we care. That's why HTML is so ubiquitous. That's why HTML works so well, because we know that HTML has a native linking capability. It has the A element, right? It has the A element, which is the link. That's why we can build browsers around that. Because browsers, now that we know that HTML has a link, browsers being the clients, can be built to adapt to that. They can be built to render that link in a proper way. They can be built to allow you to navigate. But all of that depends on the standard. All of that depends on the browsers knowing that the link is going to be there and it's going to follow those very, very strict semantics. So that's why native hyperlinking, not just haphazard hyperlinking, but native and standardized hyperlinking is super important. So how does that help the client? Why do we care about all of this? Well, first of all, a client can now, as I was saying, be built once we have the link, once we have the standard. The clients can now understand it. The clients can now navigate through the system via these links. So that is the major thing. As soon as we have this hypermedia type like HTML that supports linking natively and has a good standard behind it, and of course, as soon as that standard is actually adopted, which we're gonna talk about in a few slides, as soon as that happens, we now have the option to build, good clients around it. Now, discoverable means flexible. So, the discoverability of the API allows us to build more flexible APIs, more flexible implementations. And the reason we care about that is, of course, we want things to be flexible. We want to have an easy time changing that API. If we change our mind, or if we evolve some resource or some operation, we want to be able to do that. We don't want to be fixed in an API. We don't want to basically have our hands tied. We want to be able to evolve that API. And of course, we want to do that without breaking clients. Because if we put that API in the hands of clients, well, breaking those clients is going to be very costly. We can do it. There is, the versioning approach is, of course, a way to do it, but that's super costly. And API don't usually version. Sometimes they do, but for example, major APIs out there have 2 versions, maybe 3 versions if they've been around for many, many years. And that's about it. And they've been around for years. So what does that tell us? Well, it tells us that a version is expensive and you cannot roll out new versions very often. So we want to be able to do backwards compatible changes. We don't want to, break clients, essentially. So one way to do that is, of course, and we're going to get to that, but one way to do that is, again, to implement HATEOAS and then document the behavior of the API very clearly. All right. So changing and evolving the API becomes easier. That's obvious from the idea of, okay, we have flexibility. So now with that flexibility, we are going to change the API. We're going to change it, and we're not going to break any clients. And if we have if we have time towards the end, I'll go into a story. I'll go into a story from the point of view of just client implementations that I worked on in the last couple of years, and a few of them that got hypermedia right and were actually client facing. So meaning third-party clients were actually being built, because sometimes that is not the case. Sometimes you're building an API for yourself, essentially for your own application, and that is definitely a good use case as well. But sometimes the API is actually client facing, and that's where things become a lot more interesting. All right, and finally, the client consumes the API in a more natural way. So this is, of course, again, less important for internal clients, because internal clients, if you're building both the API but also the client, that's very simple. That's, you know exactly what those operations are, and you control them much better. But for third-party clients, if you have like a really public API, how clients experience that API, that's critical. That's critical for adoption, basically. It's critical for developers actually working and adopting your API and writing software, writing code, writing clients, writing integrations against that API. And today, most applications that want to continue evolving and living have some sort of API. If they don't have an API, they're definitely working on one. All right. So that's simple enough, right? That's understandable. We want links. We want to make good use of links. Okay, let's add links. But before we add links, we need to have a media type that supports links. I mean, that's the whole purpose here. We want a media type that has that native linking capabilities, linking semantics. That's what we care about. And we talked about that before. We said we want a hypermedia type, which is a media type that has native hyperlinking semantics. So let's see where we are with that. Let's see, do we have a media type like that? Well, we have HTML, right? Is HTML a hypermedia type? We said that definitely it is, right? HTML is, of course, a hypermedia type because it has a native concept of a link. However, is XML a hypermedia type? Unfortunately, by itself, the answer is no. XML has no concept of a link. Is JSON a hypermedia type? Again, no. JSON is not a hypermedia type because, again, JSON does not support links, not by itself. We can build something on top of JSON, and we have built a lot of things on top of JSON to support links, but by itself, it doesn't have any concept, any idea of a link. The problem is we like JSON. We want to keep using JSON. And JSON, of course, is probably the most used at this point, next to XML, not next to XML, but more used than XML. And we want to keep using it. So the question now becomes, can we make JSON hypermedia enabled? Can we make a hypermedia type from JSON? And it turns out that yes, we can. So the first one that we're going to have a look at is HAL, which is the hypertext application language. So that's one option. Let's just put it that way. We're gonna come back to it, but for the time being, that is one option. That is one option of a hypermedia type built with and on top of JSON. Now we have collection plus JSON. That's another option. That's another competing standard. But now we have Siren. This actually goes a step further, and it doesn't have just links. It also has actions. That's a pretty cool implementation details of Siren, but essentially, again, it's a good option. It's an interesting option. It's an interesting competing standard, but now we have 3 of them. Well, now we have another one. We have JSON LD. This is JSON for linked data. So linked is in the title. The main point of this one is that supposedly you can introduce JSON LD in your application without making breaking changes. That's a good selling point. That's a critical thing, right? Not making breaking changes. That's super important because if you already have an API, well, then all of these hypermedia types are hard to do. If you're just using JSON, they're really hard to do because you have to change your media type completely. You have to essentially provide a separate representation, and that's a lot of work. That is of course a breaking change for the clients, and you don't want that. And so JSON LD is a good option because it has this idea of not having any breaking changes. But the problem is now we have 4, and this is the 5th one. We have JSON API. This is a spec that makes some really good choices. So it makes some choices about how the client should interact with the API. And again, very good spec. It's one that I'm personally probably the most excited about out of all of these, but we now have 5 of them, 5 competing standards. So we can see that it's starting to get hairy. It's starting to get, pretty crowded. But the problem is we're not done. So we are not done. We now have Uber, Mason, Yahapi, and CPHL. So you can start seeing how the landscape of JSON hypermedia types is very, very crowded. A lot of competing standards, some of them with more adoption than others, but definitely no winners, which harkens back to the idea of we cannot actually create any standard until one of those standards actually wins, or maybe a new one. But the point is, until we actually have a standard and not 8 competing standards or 9 of them, and I'm sure there are others, until we have a standard, it is really difficult to build a proper client because that client does not have a standard to go against. All right, now let's go over implementation, because we're finally at the point where we're going to actually, the rubber hits the road and we're going to actually do some implementation. We're going to actually use Spring to implement some level of discoverability. I say some level because the real discoverability and the real, link building and HATEOAS support is going to come later. It's going to come when we get to Spring HATEOAS. But this is definitely interesting, and this is definitely a good way to do it if you cannot change your media type. If you want to do it, but you don't want to really disrupt your existing clients. So let's look at the create operation. And since we've been discussing the book example, we are going to stick with the book example. So we're doing a create, right? We are creating, we are posting to /API/books, and we are posting, we're setting a content type because we are going to actually send a body, right? We are creating a book, so we need to actually send that book over. And we also set the accept header because we may want to get something back, right? We may want to get something from the API. We may not, but the point is if the API gives us something back, then we want that to be JSON as well. All right, so what do we get back? So we get back the status code 201 created. That's good. That's a decent response for a create. We're gonna get back, we're getting back this content length 0, which means that we actually don't get any body back in this case. However, the interesting thing is that we are getting back this location header. So this location header tells us, okay, the book was created, but here is where you can access it. So not just, okay, it was created, but here's the link to it. Here is the location of the book. Because notice that this location, has an ID in the URI, and that ID, of course, got assigned by the API. So this is the only way to know, okay, I created the book, but now where do I get it? If I want to get that book that I just created, where do I do that? Here's where you do that. You get the location header and you get the URI from this. The thing is, Spring doesn't do that by itself. So how do we do that? Because Spring has the support of helping us to do that, but it doesn't actually do that. So when you do a create, you're not going to see that location header on the response. So here's how you do it, right? You get the ID of the book, you're specifying the path. Of course, this is slightly hard-coded, but you can be more, more flexible here, but this is a simple example. You're getting the ID, you're defining the path, you are creating this location header, the value of this location, and this is where Spring helps. This URI builder, this Fluent API, is really super, super flexible, and it's essentially just one line, right? It seems that there are 3 lines there, but no, it's just one line broken so that it's more readable. And in one line, you can create the link. And the link is going to be relative to the to the host and, of course, the server path and all of that stuff. That's good. It's going to be relative. It's going to be correct. And then once you have the location, once you have the value of that link, then you're going to just set it on your response. So nothing fancy, nothing complicated. You just say set header, you're setting the location header, and you're putting that value in your response. So that's a good way to do it. And remember that this doesn't involve any breaking changes, because what you're doing is you're setting a location header. You're not changing the response type. You're not changing the body. You're not doing anything that then setting this header. So that's pretty backwards compatible, right? Now let's look at the get one. So this is another operation. You're going to get a single book. So we're getting this book. We're doing a get this time, of course. We are specifying the accept header again. And this time we definitely know that there is going to be a body, because that's what we're asking for. We are asking for the book. And here's what we're getting back. Of course, the body as well, but I'm just showing the headers. So we are going to get back the 200 OK. That's fine. That's good. That's what we expect. We're getting back the content length, which this time it's not 0 anymore. So that's good. We are getting back the actual body of that book, right? We're getting back, the book in the body. So this is again expected. We're getting the content type, again expected, application JSON. This is what we have been asking for. But now notice that we are now pointing to the collection. So we're retrieving a single book, but now we're pointing the client to the collection of books. If they want to, after retrieving this book, if they want to actually retrieve the collection as well, this is how they do it. So they can follow this link and they can get all of the books in the system. So how do we do that? Well, so now that we see that we can discover the entire collection, let's see exactly how do we do that. So the first thing we do is we are defining this collection URI. Same thing we did last time. We're defining the URI. We have this create link header, because remember, let me go back and let's look at the structure. So this is a bit of a custom structure, right? It's not like just a link. It's a link with a rel type, so a relation. So that needs to be constructed. And once that's constructed, we simply set the link header. So again, this link header is the cool part, is the interesting part, because this link header allows us to return links back to the client without putting those links in the body, without modifying our body. Because if we now need to put links in the body, all of a sudden we need to modify the body. We need to make sure that the body actually, includes those links. So that may be a breaking change. It's not always a breaking change, definitely not, but it may be a breaking change depending on how you implement it. However, if you do it via the header, you don't have to worry about breaking change because presumably you weren't using the link header and now you are. So clients that don't have any clue about the link header, well, they're just going to ignore that. That's fine. They don't care. But new clients or clients that actually do look at the response, well, they're going to benefit from those links, but you don't have to change your body. So that's kind of the good thing. Now, of course, the bad thing is that there is some low-level work, right? You can see that we're setting this header on the response, and we're interacting with this URI mapper, and it's not really very clean. It's not really very, very nice, right? So we don't necessarily want to do this low-level stuff. We'd like to create those links a lot higher level. We'd like to make sure that we create those links in a nice, clean, high-level way, and we don't want to, double every mapping that we're defining. We don't, because every time we change a mapping, we have to remember to change it here. It becomes complicated. So we can do better, right? We can, using these HTTP headers is non-breaking, but it's very limited. We can definitely do better. And we are going to do better by stopping this use of raw JSON. We're not going to go just raw JSON. As we saw, raw JSON is not hypermedia enabled because raw JSON has no concept of a link. So we don't want raw JSON. We want something better. And HAL is definitely better. Now, we picked HAL because there's good support for HAL in Spring HATEOAS and in Spring Data REST and in the whole Spring ecosystem. However, even if we don't pick HAL, even if we pick some of the other alternatives, it's essentially the same idea. We don't want raw JSON. We want to use something better. So now we are at the point where we actually start looking into Spring HATEOAS. We actually start looking into, okay, what can we use better? What can we do better? And how can we actually build these links in a more intelligent way? Are we really restricted to building those links like manually and having those mappings duplicated like that? And obviously we're not. Spring HATEOAS is a project that came out of essentially a lot of client engagements. So basically the Spring team and kind of the core team helps with client engagements as well. And big clients needed these kind of capabilities. So clients were using the low level, the manual way of doing things. And so Spring Data came about as a way to address that problem and as a way to essentially do better. Just provide a much better, simpler, easier way of creating those links and returning those links. And this is where the project comes from. All right, so let's look at Spring HATEOAS. So Spring HATEOAS essentially helps us build out these links in our responses. So not in our headers, but in the actual response. Now that of course has a few interesting repercussions, right? Because as soon as you need to provide this into your response, well, if you're starting a new API, that's fine, that's great, because you have that option. If, however, you're not starting a new API, if, however, you are creating this, you're introducing this into an existing API, well, all of a sudden you have the question of, okay, how do I do that? So the way you do that is you transition your existing API with basically changing your controller layer. And there are simple ways to do that, but be aware that it's still some work. So it is definitely still some work, depending, of course, on the complexity of your controllers. So if you have a few of them and they're well written, it's really easy. It's going to be a couple of hours of work. If you have a lot of controllers, or if you have controllers that maybe not so great, so well written, well, it's going to be a couple of days. And I've done many migrations that do this, and basically that's the range. So from a couple of hours for a clean, simple or medium system, to a couple of days of heads down, just moving stuff around, just moving, essentially changing the return type of controllers, changing all of those data, DTOs to new DTOs, right? So it's some work. However, 2 days is really not that big of a deal. Even in a complex system, a few days are enough to migrate the whole thing. So it's still pretty simple, a pretty simple implementation, even for very complex systems. But usually it doesn't even take that long. So now we're getting support for hypermedia types such as HAL. And I say such as HAL because supposedly and theoretically it supports other media types as well, although HAL is the more complete implementation. But in the future, there is going to be support for other media types. And the cool thing about that is that when you have the new support, you're not going to have to change anything else. HAL is just a strategy or a media type, but you can switch between HAL and other implementations. But anyway, for our purposes here, HAL is the go-to. HAL is the most complete, and it's essentially the reference implementation. So first of all, how do we add HATEOAS? So you can add Spring HATEOAS to the project by, of course, just defining the Maven dependency like this. By the way, this is provided you're using boot, and you don't have to provide the version. If you do have to provide the version, the current version is 0.19, and yeah, you basically have to define that manually. Or if you're using boot and you don't want to define the actual dependency, well, you can use the boot starter. So there's a boot starter for HATEOAS, and that pulls in everything you need. So you can bring in your support either manually or with the boot starter. Either way is fine, of course. Now, once you have support, once you are using Spring HATEOAS in your project, you have the option to roll out, to implement a resource. So this is a first resource. And of course, we're using book, right? We're following this book example, so we are going to keep using book. So let's look at this resource and let's understand what's going on here. So the resource is a simple podro. The only important thing here is that this is extending the resource support. So the resource support is their implementation, their base class out of the framework, out of Spring HATEOAS. And as long as you extend resource support, you're good to go. So that is pretty much all you need from the point of view of defining this resource. And then you, of course, just have your standard fields, your standard stuff, so nothing changes. However, if you're defining this resource for an existing API, you can also have a wrapper. You can basically create a wrapper, and you can simply wrap your existing resources, right? Your existing DTOs or whatever you're exposing. So, and the reason I mention this here is that this makes migrations really easy, because once you do that, once you only have to wrap the resource, the new resource, and you're basically wrapping the old one, well, migrations really become a thing of just wrapping and unwrapping. So that's why migrations are pretty clean and pretty easy. And of course, once you have that done, you can evolve that resource. You can, at some point, you can, of course, do the extra work of, removing the wrapping part and just putting the fields right into the resource. But the point is, you don't have to. And the other interesting thing is that there is actually a wrapper resource that is defined in the framework. And this is what it looks like. So you can actually do even better wrapping if you do this. Because notice that let's step back for a second and let's look at the old one. So the old one has the book inside this resource, inside this implementation. Well, the new one doesn't. The new one extends a resource. So the old one was extending resource support. The new one is extending resource. And so you don't need to provide anything else. Everything is taken care of, and that's a wrapper. That's basically how it looks. So you can see why migrations are that easy. All right, now let's have a look at our first controller. So we have this controller, and at this point, this is a standard controller, but notice a few interesting things. So notice, first of all, that this find by ESBN API method is pretty standard, but the only thing that is different here is that this is returning the book resource. So this new resource that we have defined. And notice how we're returning that. So we're simply wrapping, like after all of the logic has run and we have our response, we have our book, we are simply wrapping that book inside this book resource, and we're done. We're wrapping it, we're returning it, and that's about it. So that's a very simple, of course, implementation, but no matter how complex the implementation gets, no matter if you have just a simple find or if you have like 100 lines there, the point is that the wrapper only comes in at the end, right? So you're wrapping this at the very end when you're returning from the method. So that's, again, part of why migrations are easy. All right, now let's look at the book. So let's look at how the book used to look without any links, right? So this is a book JSON, right? We have the ESBN and we have a title, and that's it. There are no links, there's no other information. That's pretty much the whole book. Of course, in reality, you're not going to have 2 fields. You're going to have 50 fields or whatever. You're going to have a lot more fields, even for a book. If you look at an Amazon book, it has a lot of fields, a lot of details. This is just a simplified version. So the first link we are going to add, the very first link, is the self link. And it's a good practice to include this canonical URL, to include this self link in each and every resource. And the reason it's good practice is that the resource may be accessible on a lot of separate and diverse URLs or paths, right? You can, of course, access, for example, books just at /books. That's option 1. However, think about a more complex system. So if you have authors, well, all of a sudden books now become available for /author, /ID, /books. So maybe you're accessing the books of a specific author. So then the URL changes, right? And of course, books can be displayed and accessed. Maybe you have a library, and then the point being that you can access that book in a lot of ways. So child resources, embedded resources, a lot of varied ways of accessing the same thing. So that's why a self-link is super useful, because wherever you're displaying that book, at the end of the day, you know what the canonical URL of that book or of that resource really is. You always know, even if that's an embedded resource, even if the URL is funky and has a lot of stuff in it, at the end of the day, okay, that's fine, but the URL, the canonical URL, is this simple one. So you can have that advantage, and that's why it's important to have a self-link. Now, let's add this self-link. So now that the book is a resource, now that we're extending that base class from Spring HATEOAS, all of a sudden we have this add method. So we have this add method, and we can add links. This is the power of this framework. It allows you to add these links whenever you need to write in the resource. It has support for them in the base class. So you can now simply add links. So this is what we're doing here. We are adding this link. Now, let's have a look at the link, right? So we have a new link, and we are specifying just the full URL. right? And of course, at the very end, we're saying with self-rel. This is going to make it a self-link, but the point is we are specifying this hard-coded full URL. Now, we definitely don't want to do that. That's not a good idea. That's only going to work if you're deploying on localhost 8081, right? If you deploy on anything else, any other host or port, that's it. It's not going to work anymore. So you don't want to do that. Now, what you do want to do is you want to make the link flexible, right? And this is a way to make the link flexible. We are no longer hard coding the host and the port, right? We are linking to the current mapping, and then we're saying /books/ the ESBN of the book, and that's it, right? So we got rid of the hard coding. That's fine. But the problem is we're still basically defining this mapping. We're still saying /books/ ESBN. The problem is if we change that mapping, if the controller changes, well, we have to remember to change this part as well. Because if the controller changes, because we're specifying the mapping twice, right? Once on the controller, once on this URL builder, the problem is, again, we change one, we have to change the other. That's not ideal. That we don't want that. We're specifying these mappings once. We don't want to specify them again, right? So that's the whole point. We want to get rid of this part as well. We want to be fully flexible. We want, if something changes in the controller, I want all of my links in the whole system to change with it. So this is what we want to do. We want to manually build these URLs. So let's try now, right? Let's try to point to a controller method instead. This would be much better. This would be ideal. If we could point to a controller method, if we could not, if we could benefit from the fact that the controllers already have the mappings, right? The controllers already know all of that stuff. If we could hook into that part, if we could benefit from all of that mapping information, that would be ideal. That would be what we want, because again, the controller already knows what the mappings are. So that's it. If we can link to those, that's ideal. So we don't have to duplicate our mappings. Of course, as I was saying, we would only specify the mappings as we do normally on the controllers, and that's it. So let's see how we do that. Because of course, that's the power of this framework, is of course that it is a Spring framework. So it knows all of that handler mapping stuff. It knows all of the mappings. It has all of those available, and it integrates with Spring MVC. That's why this is powerful, because it integrates with all of that. So this is, for example, how we do it. We can link to, and this is the new syntax. We have this method on, so we can specify, okay, which controller, and not only which controller, but which actual method. So for us, it's find by ESBN, which we just saw. And now we are pointing to a controller, and not only to the controller, but to the method in the controller. And so we are no longer specifying any sort of mapping. We are now fully dynamic, and we can say, okay, method on, controller, and then the method. So fully dynamic. If something changes in the controller, something will implicitly change in here and with the link. So that's the ideal, and that's where we are. Now, this is another option, right? You have this link to, and you can still use the /. That's a pretty cool hack. You can use the hash, and you can provide the ESBN. That's still slightly less dynamic, but it works quite well. So these are the endpoints. These are the two ways to do this correctly, to do this right. All right, so let's now see how this looks. So this is how it looks. This is the JSON with a self-link. This is no longer just the JSON, but this also has the self-link. And we can now see we can now start understanding how this whole thing looks in production or in practice, right? We're no longer just getting the details of the book, we are getting the links as well. So this is essentially the actual response of that. All right, let's move forward. So now let's add a buy link, right? We don't just want a self link. A self link is great, but that's not enough. So we want a buy link, or we want some other links. Just a buy link is just an example, because that's the whole point of this example. We want to be able to buy the book. But that's what we want. We want to be able to build this operation and essentially to drive the client through this flow. We want to help the client go through this flow with our links. And so what we're introducing here is we are introducing a buy link, right? The rel type is buy, and we're pointing to this operation. We're pointing to this add book to cart. And so that's essentially our buy operation, and we now are including that as a link. So let's see, with that in mind, how the JSON looks with the new buy link. So the JSON with the new buy link, now it has, of course, the self link as before, but now it has a buy link, which is this /API/cart. And this is essentially our buy operation. So what that tells us is that, if someone's, and we're going to go through a full scenario in a second, but what that tells us is that if you want to buy this book, this is where to do it, right? If you want to buy this book, you should buy it. The operation is going to be in here, at API cart. All right. So before we look at a full scenario, before we actually go through the full RESTful HATEOAS driven scenario of buying that book, right? Because that's what we want. We want a practical scenario. We want a scenario where we can actually interact with an API and get a book. Before we do that, let's take a step back, right? Let's take a step back and let's see why it's really a good idea to sit down and think about how our system, how our application is going to be used by clients. Let's have a look at that. So what we care about here is, what are the common interactions? How are clients going to be consuming our API? And it's certainly true that some applications cannot do this, right? Some applications are still are complex enough where you cannot actually determine how a client is going to interact with that API, because if you're, for example, implementing the Google Maps API, who knows? Who knows how the client is going to interact? Like, you're going to have 100,000 clients. Each of them is going to want something different. If you really are implementing something of that range, that's fine. And you're just going to have to provide very granular operations, because anything can happen, right? You need very low-level primitives, and users can do whatever they want. However, what is important to realize, and this is a common misconception, is that most of us, 99% of us, are not building the Google Maps API or an application of that kind, right? Most of us were not doing that. So, and the reason I'm saying this is a common misconception is that in client engagement, after client engagement, I see this mistake of basically not sitting down and thinking through how these scenarios play out. Like, not everything, but what are the common ways that a client is going to want to do when they interact with your API? What's the common stuff that they all or most of them want to do? Not thinking through that is going to make, essentially just a worse API. And thinking through that, conversely, is going to just make a better experience for that client. So for most systems, it's clear how they're going to get access. It's clear how they are going to get consumed. Now, that doesn't mean users might not step outside the rules. Yes, users should and might step outside the rules and should be able to, And you definitely don't want to make it so that anyone can't do anything that's not expected. However, it's important to think about the common scenarios, the main drivers, the main scenarios that users are going to have. And it's important to optimize for that. It's important to think through that and really make sure that those work well. So that's basically going through the common stuff. And most developers don't do this when developing APIs, and that's really a shame. So that's if one thing is going to be kind of a takeaway from this beyond the practical stuff, beyond the tactics, this is a strategy that improves the API in 99% of cases. So think through API chattiness. Think through the payloads, right? There are common decisions here, right? Are users going to do small calls and a lot of them? Is the API very chatty? And are you optimizing for those scenarios? Or are users going to work with huge payloads? And that means minimal chattiness and minimal API calls, and means multiplexing, and means keeping things very minimal in terms of how many requests. So what your API optimizes for is going to be decided on these common scenarios, right? Also, are you expecting users to have a stable connection, a desktop connection? Or are you optimizing for example, mobile, where connections are intermittent? So all of this is essentially going to decide the architecture and the granularity of your API and your operations, right? Granular versus non-granular. Assumptions made versus no assumptions made. So that's the step back I wanted to make here. All right. So this is basically thinking through these scenarios and thinking through the decisions that you're making is going to essentially lead to a better API. Now, alternatively, an evolutionary API can also be great. It's just a lot more work to get there. So if you want an evolutionary approach, if you want to evolve your API based on user patterns and user scenarios, expect to get there in a few more versions. So I've seen both play out. That's why I'm saying evolutionary works as well. It's just that it comes with a lot more cost, right? So I've seen, for example, APIs that were built in a certain way in version 1, and then evolutionary design came in. Essentially, patterns formed, and the second version or the third version in one case was built around those patterns. So essentially, with a lot more cost and with a lot more transition, they got there as well. Again, just more work. All right, so now let's get back. Let's get back to the implementation of buying a book, right? This is going to essentially be the scenario that we had before, the buying book scenario, right? Buying a book, adding that book to cart, and buying the cart. But now we're going to do it with our actual example. And by the way, when I say actual example, this is an example that is fully implemented. So at the end of this, right, at the end of the workshop, in the wrap-up email, I'm going to share, of course, the GitHub repository where everything is implemented, and you have the practical examples working and ready to be used. So if you have any questions or anything like that, that's essentially the implementation, and so feel free to dig deep into that one. All right, so let's start at the root. We are going to start at the root of the API. We're just going to get localhost/API, right? That's it. We don't know anything about this API. We start at the root. We are accepting JSON, and in our case, we can of course accept HAL as well, but we're accepting JSON, and we are trying to discover like what's in this API. Like, just give me the root. And this is what the root looks like. So we can see that this is a simple system, and we can see that we have a book, and we now see where that is. We see that this is at /API. Well, it should have a /API in there, but anyway, it's at /books, and the cart is at /cart. Okay, so pretty simple system. What do we discover next? Well, we can do a get on the cart, but since we haven't added anything on the cart, it's just going to be empty, right? So let's do a get on /books. We want to do a get there, and we want to figure out, okay, what books do we have in the system? I want to buy a book. Let me see the books. So we're gonna get this AP. We're gonna do this get at /books, and this is what we're going to get back. So in this case, we just have one book. Of course, in a practical scenario, you're going to have a lot more, maybe some pagination as well. But the idea is that we're getting the books, right? In this case, we are getting the Gone with the Wind book that we saw before. We're getting this JSON. It has the ISBN and it has the self link, right? Which I skipped here because of the kind of the, where is it? Yeah, the self link, which is /API /books/ISBN. So we have the URI of the actual book. Okay, so we have that URI. Let's now try to buy the book, because that's what we want to do, right? We want to buy the book. Well, we've discovered what that URI is. We know what that URI is. Well, let's do a get on it and see what we have there. So we are going to follow the link to a single book, right? We're going to follow the link. We're going to get /API /books/ the ISBN of Gone with the Wind, which by the way is the actual ISBN of the book. And we are going to see what's there. All right. So we get the book. We see the self link, right? It's skipped here, but of course in the final JSON, it's there. And we see the buy action. So we see the buy action, and we see that we can buy this on the cart. The resource that we care about here is the cart. This is the cart resource is essentially where we can buy this book. Okay, so now we know where to buy it. How do we do it? Well, I skipped a bit here, of course, but you can explore this resource. You can do a get on it. You can kind of see it. You can figure out, the point of the resource is that either all verbs, all HTTP verbs are available on it, or of course you can do an options on the URI and figure out what verbs are available. So if you do an options on the cart, you're going to see, for example, that get is available, of course. A delete is available. You can delete the cart, or rather clear the cart. And the post is available to create. And that's about it. Well, no, actually, there's another one, but we'll talk about it later. So you figure out, okay, a post is available. That's great. So let's do a post. We do a post on the cart now. So we do a post. We pass in the JSON of the book that we want to buy, because remember, we have that, right? We discovered that in the previous operation, and we have it. So we do this post, and we pass in as the body the JSON of the book. And this is what we get back. So we get back the cart. Now this is the list of books in the cart. So that's pretty cool. We have the books here. We can see that this cart is not purchased. We can see that purchased flag, which is false. And we can see the self link of the book, of the cart. Now, keep in mind that this is a simplified kind of JSON. There would be a few more things here. For example, maybe the books have links. Maybe they don't. We'll see. We can talk about that later. But the point is, it is simplified, but it's actually very close to what you would have in practice, besides the fact that there would be more fields. So now let's look at the purchase flag. So we see that purchase flag, and we want to purchase the cart. That's our intention, right? We want to trigger a purchase operation. However, if we look at the links, we cannot figure out, like, okay, what is the purchase operation? Because I only see a self link there. I don't see any buy link or any purchase link or anything like that. I just see a self link. However, I see the purchased flag, right? This is false right now. Now, what do we actually want to do? Well, we want to make this flag true. That's essentially what we want to do. That's essentially, in a simplified way, the purchase operation. So purchasing the cart doesn't map to any standard HTTP verb. We don't have a verb for purchase, right? That's a problem, but that's only a problem if you're not necessarily yet accustomed to the RESTful architecture. When you start getting accustomed, you're going to see the purchase operation is modifying that resource. So what do we want? Well, let's go back. We see the purchase flag. We see that that's false. We want to make that true. So then we're starting to see how that's going to work. We're going to try to mutate, right? To change, to update the resource. And we're going to try to change that purchase flag to true. That's pretty much it. Of course, a payment operation is a little bit more complex than that because you have to actually go through a banking system and so forth. But we don't really care about that here, about the banking, like the interaction with the banking. So we care about purchasing it from the conceptual way, right? So we want to change that flag to purchased. So the interesting thing here is that when you do that, when you change the flag to purchase, the server will do or may do all sorts of things. We may do all sorts of operations. So just because you said that something should be in a particular state, in our case, just because we're going to say that the cart should be purchased, that doesn't mean that the operation is immediate, right? There could be intermediary operations, and this is where the banking system would go, right? The interaction, the card, all of that stuff. But the point is we want to trigger the flow of making that card purchased. This is not CRUD. This is not just, oh, I'm making a request and that's it. It's an update. This is not CRUD. It's essentially changing the resource and updating the resource to become purchased, right? So if you take that idea, the end state of the resource is pretty clear, right? We just want that card to be purchased. And so let's see how we implement that. Right, and this is just a quick note that if you do a get right after you send the original request, you may see one of those intermediary states. So for example, if purchasing the cart, right, purchasing that book takes 5 minutes and you do a get after 2 minutes, you may see, a kind of an intermediary state. But anyway, let's actually get to the implementation and let's do the purchase operation. Let's implement that. So this is how the purchase operation looks like. So let's see what we're doing here. We are using the patch HTTP verb, and the reason we're using patch and not put is that this is not a full update. This is a partial update, and put is not allowed to do partial updates. Remember that in the HTTP specification, put is a verb that cannot do any partial update. Essentially, put is a full replace. Put is a full update. That's the semantics of put, and that's the only available semantics of put. So if you're using put for a partial update, you're using it wrong, right? That's very simply the gist of it. The HTTP spec basically creates the patch verb for partial updates. So we are using patch, right? And we are basically just, and that's the cool thing about this, we are just putting this purchased flag to true. That's all we're doing. We're not passing any other details. We're not, and this is why this is cool. This is why this partial update is so cool, because you don't have to pass in a lot of extra detail. You don't have to do, for example, you don't have to pass in the whole cart with the books, with the links, you don't have to do that. You just have to pass in the partial update, which is just the purchase flag. So pretty cool, pretty light. And now let's see what we get back. All right. So what we get back in this case is the purchased flag set to true. And of course, we get back the whole cart. So we got back the full cart, and the only difference here is that the purchased flag is now true. So that is how we purchased our book. And that is what this entire scenario looks like without looking at any documentation, just discovering each and every next step. We did one step, the system points us to the next step. We do that step, the system points us to the next step. We do that one. So basically the system assists us and points us to the next step and to the next step and so on. So pretty powerful in terms of implementation, and of course pretty flexible if you want to change any of the details of this. If you want to actually change anything, pretty flexible. All right, so let's go forward and let's see how we are going to do a kind of a view of a resource, how we can actually have less detail. If we have a big resource, if you have a large resource, how we can trim that, how we can provide a lightweight representation of that. So our book implementation is relatively simple, right? Our book implementation has 2 fields, so it's not really that complicated. However, a real book implementation, a real book JSON, that's going to have a lot of fields, and I really mean a lot of fields. I had a look at a few examples when I was developing this scenario, and a lot of fields. Now, if we get one book, that's fine. We get a lot of fields, that's okay. However, if we get a list of books, if we want to get the books list, the collection resource at /books, that's no longer okay, because that collection resource may have 100, even if it's using pagination, it may still have 50, 100 books. If you're returning 100 books and each of those books has 50, 100 fields, well, that's not good. That's never good, but especially for mobile clients. If your API is returning that kind of JSON and that kind of payload to a mobile client, that's definitely not good, because that mobile client is not equipped to handle such a payload, and it's just going to freeze up. Now, of course, that may be the case. Newer mobile clients may have more of a leeway there, but it's never a good idea to return that much data. Not only is it not a good idea, but it's not necessary. Most tables or most whatever you're displaying, if you're displaying a list of books, you're probably only displaying titles and ESBNs and a few other stuff. You're not displaying, weird details like, I don't know, let's say the first date of publishing, of the first edition of the book, or things that are essentially not going to be displayed. So you don't need those things on the list. So how do you get rid of them? Right? When we get a list, we basically want less data. We want a lot less data. Now, we don't want to do that manually, right? Because if we start doing, you could do that manually, right? You could create another DTO, another resource, kind of have a conversion, have a mapping, go from one to the other. You could do it manually, and that's fine. That's doable. The problem with doing it manually is that if you do it for one resource, it's not adding that much complexity to a system. If you do that for 50, 100 resources, it explodes the complexity of that system. It blows that up. You don't want to create new classes and conversion logic and all of that stuff just for this use case, because there are going to be other use cases. So it's going to become too complex. What you want to do is you want to benefit from a smarter mechanism. You want to benefit from something that is going to enable you to say, okay, for this operation, show fields 1, 2, 3, and for this other operation, show 4, 5, 6. And so you want that kind of flexibility, but you don't want to create 100 classes. This is how you do it. Jackson and the JSON view annotation is pretty cool. So what that allows you to do is first of all, you define a view, right? In this case, we have this summary view, right? So the summary view means when we get a summary of a book or of a collection of books, we're only getting the fields that are annotated with the summary. We're only getting, in this case, the ESBN. We're not getting the title. We may not need the title, and so we're not getting it. After you define the view, and after you use the annotation on the proper fields, now you can enable the view on your controller method. So you enable the view with the JSON view annotation, and there you go. That's it. Once you do that, the find all operation no longer returns the full book. The find all operation now returns the summary view of this particular book, which is pretty cool. This is how this would look if you're not using summaries, right? This is this is just one book, right? But this is, of course, a list. So if you're returning 100 of these, even with 2 fields, it's still a lot. This is how it looks once you're using summaries. A lot cleaner. So again, without summaries, with summaries. A lot cleaner, a lot lighter on the wire, a lot less information, and a lot more control on our end, right? A lot more control without defining a new class, without doing any conversion, without doing any of that. So pretty cool mechanism, and one that, especially if you're working with mobile and mobile clients, it's going to come in really handy. Now, what if we need more control? What if it's not enough to say, to decide on the server side what a summary view is? What if we want the client to decide that? What if we want the client to say, well, I need the title and I need the date and I like a few fields. I don't need anything else. Like the client knows, at the end of the day, the client knows what it needs, right? The client knows that if they're populating like a table or something like that, they know exactly the fields that they need. They know exactly what a summary is for them, right? For that particular scenario and for that particular client, they know. The server side may know as well, but you don't necessarily want to make that decision on the server side because the server side may not know. Like if a third-party client comes in and wants to show an extra field on the table, just for some reason they want to show that extra field, what do? Well, now you're forcing that client to basically get the full view because they cannot use the summary view because the summary view doesn't have that extra field. So if that's the case, then you are stuck. All of a sudden, the client is now, forced to get the full list with the full representation, which, as we've said, not ideal. So what we want to do is we want to get a book, or of course a list of books, and we don't want to get this predefined representation. We want the client to be able to pick the exact fields that they need. We want the client to say, and we're going to actually see an example. We want, for example, the client to say, I only want the title, right? Not the ESBN, I just need the title. So this is what it would look like, right? The client would do a get for API books by ESBN, and they would say, I only want the title. Out of all of the information you have about the book, in our case, not that much, but in a real system, a lot, we just want the title. So how do we do that? Well, we do that with a JSON filter. So we have our book resource. We are defining this book filter on our book resource. We can do it at the getter level. We can do it on the book. It doesn't matter because it does the same thing. And now we are getting the fields. Of course, the fields are coming from the client. In our case, as I was saying, it's just a title. And we are defining this filter provider. So this is a Jackson filter provider. It's a simple one. It adds this book filter, right? And it defines this filter out all except fields. So what that means is that it's filtering out everything except the fields that we are asking for. So this is the flexibility of this solution. It's only going to show us the fields that the client is explicitly asking for. And at the controller level, all you need to change is the return type. So no longer just returning the resource, now we are returning this mapping Jackson value that is wrapping the resource. So that's basically the kind of the cost of this flexibility, is that you have to change the return type. Now, of course, this is an extra operation. This is not necessarily replacing your old operations. It's adding new capabilities to the API, and it's adding a very nice capability, a very useful, very practical capability, which is, a filtered, a fields acceptance, right? So the client asks for fields, you're providing only those fields. So very, very powerful in terms of what you can do with it. And this is what it would look like. So for example, we are asking for just the title field. So remember that the book had the ISBN as well. No longer we're looking at that. We're just looking at the title. And here we go. So this is what it looks like, right? We're getting back the book, but we are not getting the ISBN. And again, this example is a simple one, but keep in mind that if you have 50 fields here, this is essentially really cutting down the data on the wire. This is going to cut down that data a lot. Not only the data, but the parsing process, all of the memory consumption on the client side, all of that stuff is going to be very, very clean and small and lightweight when you're actually allowing your clients to ask for what they need, right? Just ask for the data they need. So super powerful, a technique that, I added to some of my clients' APIs after the fact, not during implementation, but way after the fact. And then we kind of saw it being picked up, right? Slowly, but definitely an uptrend, like definitely a lot of usage after a while, but basically, kind of abandoning the old ones, right? Because the old ones are still there, like the find alls and the paginations and all of that are still there. But the filtered methods, the one that actually accept fields, are getting a lot more usage. So we're getting a lot more usage last year when I checked. I'm sure now they're getting a lot more for that particular client implementation. All right, so the final scenario that we can have a look at, right? Just an interesting scenario that I wanted to mention. It's more of an advanced scenario, and it's not necessarily a focus here, but I mean, all of these have been advanced scenarios, but this one is just an interesting one that I liked. And this is the embedded resources in HAL. So HAL supports this embedded type of resource. So basically it supports you embedding child resources in a parent. And what I like about this is that you can either embed the whole resource, like just put the whole thing in there, or you can have a link to that resource. So that's why I like the implementation here, and that's why I wanted to include it. And it's something that in some situations having the links will save a lot of bandwidth, and it's essentially going to be a very simple way to say, okay, these are the links if you need them, but if you don't need them, you can just ignore them. You're not overloading that resource representation with a lot of extra data. So if they need the links, they go to the links. Like if the client needs them, they can get them, but you're not forcing them to download and get that whole data in a single pass. So you can use the resources base class. So this is a pluggle. Notice the pluggle. So the Spring HATEOAS project has a resource. It also has these resources base class, and this is basically what you can use if you want to build out a collection here. And by the way, I included an example of this in practice in the code base, so you can have a look at that. Now, the option again is either to embed the full resource, so that's an option, or you can just provide the link. So that's the kind of the really cool part, is that you can just provide the link, and then the system doesn't force the client to get a lot of extra detail that they may not need. So that is the final advanced scenario, and that should wrap us up. So hopefully this was all kind of practical stuff towards the end. Hopefully all of this stuff is starting to get your wheels turning, is starting to see, you're starting to see practical ways you can actually improve your API, add stuff on top of the existing operations, add stuff that essentially can improve the experience of your clients, improve the usage, improve, for example, bandwidth utilization, things like that. So hopefully this is what this does, right? Diving through the code is probably going to help as well, right? So that's the goal of the code, and I'm going to make that available when we wrap things up. But this is basically the idea. It's to improve your APIs in such a way that, again, you're not breaking any clients, but you're adding new capabilities that are better. And over time, right? Over time, it's not going to happen immediately. Clients are usually going to pick those up, right? If they're sophisticated clients, they're going to benefit from the new ones. And if you're tracking, and you should be tracking, you're going to see the usage of the old stuff go way down. Over time, you're going to see, the new operations picking up and the old operations going down in terms of usage. So this is what I've seen in client implementations, and at least in systems that, after we wrapped up the implementation, I'm still checking in to see usage. And at least in those ones, that's usually what happens. All right. So I'm going to go grab a coffee. I kept this workshop pretty self-contained. I kept it at 10 people. And of course, there's not a lot of questions. So that's, initially, but feel free to ask me questions after the fact, right? So email me with questions, ping me on Twitter, anything like that. Feel free to do that. All right. I was reading a quick question from Zen. So the question is, I'm not sure I understand the difference between using resources or just using links for discoverability. So if I understand the question correctly, if you're talking about this embedded stuff at the very end, so, okay, let me actually ask, because we are live, so we can do that. Are you talking about the embedded notes that I had at the end, or are you talking in general using resources or using links? Because these are two different things. And, while I'm waiting for the response, I'm going to assume that you're talking in general, like, using resources or using links, right? And that's a good question, but these are terms that are not one versus the other. So you're not using resources or just using links. No, you're adding links to your resources. So you're still returning, your API is still returning the resources. However, along with those resources, you're also adding links. Okay, yes, cool. So I made the right assumption. So essentially, you're still returning resources, right? If you're not returning links, well, then your clients need to go to the documentation. They need to kind of dive into the documentation of the API to figure out what they can do next. Oh, all right. Let me stop right here, because Zen has clarified, and he said you meant with the embedded stuff. No, the embedded stuff, so the embedded functionality in HAL is not necessarily, so the embedded functionality is just a syntax, right? It's essentially the idea of having this embedded element in the JSON, and just a bit more semantically rich way of saying, okay, this is a parent and these are the children, right? So that's the embedded, and you're going to get a list of children. However, the difference that I was talking about is as follows. Think about, for example, an author, right? You're getting an author JSON. You're getting that author, you're getting, number of books published and years of activity and a lot of fields about the author. And then you're getting the books of that author. Now, you may want to get the author, and when you're getting the author, you may want to get just the links to those books, because you may not want to get, if that author has written 50 books and each of your books has 100 fields, then just getting that author is going to give you 50 books plus 100 fields of each, like a lot of extra data. So you may not need all of that, right? Now, if you're using the filtered stuff that I just talked about, or if you're using some of the other advanced functionality, that's great. You can pretty much, pick and choose what you want. However, if you're not doing that, if you're using just getting the author, well, you may not want to get the books with the author. Again, that's a lot of data. That's a lot of extra data that you may not want. So what's easier here is essentially providing not the actual books, not the full books, but links, just links to the books. So that's, it's not necessarily about discoverability, it's just about payload. So minimizing the payload. All right. Hopefully that clears things up. In the meantime, let's read another question. So from Kevin, about the book example. Let's say we upload an encyclopedia set. How would a set of books be uploaded and get links to all the books in the set? I'm trying to get up. Okay, so you're basically asking, how would you do a batch upload, or essentially a batch create? So that's definitely an interesting question, because if you're doing batch operations, everything that corresponds to essentially returning links, even if you're using the syntax right, the semantics around it are very free. So what that means is you can pretty much do it however you want, right? There's no strict semantics around it. So you could, for example, simply return a collection that just has links. So there's nothing stopping us from doing that. So for example, right, you're uploading 50 books, you're getting back a collection with links to those books. That's fine. That's discoverable. That's giving you back the information. And again, there's no clear way to do it in terms of of the format, right? So it's not like you're breaking anything or you're diverging from a way to do it. No, the format specifies the type of data you can return, but how you actually shape that data, it's simply application specific. So that would be a simple way to do it. You would simply return the collection of links, one for each book. So that should hopefully sort things out. But of course, if not, or if you have additional stuff, definitely let me know in the chat. I'm going to just grab a sip of my coffee. All right, so let's wait. I think the Hangout is slightly behind. So slightly behind, meaning there's a slight delay in the Hangout. It's not actually real time. It's, I think, 30 seconds or something. So if that answered your question, Kevin, let me know. Or if you want to kind of dive deeper into that, I'd be happy to. I really enjoy talking about HATEOAS and discoverability, because just in general, I find that when I do a client engagement and I see kind of the impact of some simple tweaks like this, like simple operations that, like for example, the field stuff, is when that became available. By the way, some of this stuff is pretty new, like the JSON view, for example, is supported, I think, from Spring 4.1, I think. Anyway, I'll have to look it up, but I think that's about it. I see just the impact of just usage, right? That's the reason I always try to follow up with past clients and see usage, because basically I want to see kind of how much adoption the new stuff gets versus the old stuff. So it's pretty crazy, like a few operations, like what they can do for clients, for clients of the API, I mean. All right. My voice is pretty much gone, so I'm going to wrap things up. Thanks, guys, for attending live. Of course, all students are going to get the recording. I mean, workshops are always going to be recorded and always going to be accessible long term. And so you will get a link to the recording. And also, of course, when I run the workshop again, and by the way, I'm presenting the the advanced API discoverability in a few days at GCon, and then in a few more days at Spring IO Barcelona. So maybe maybe that's going to refine or add some examples, because I'm still going to add some stuff in the talk. So yeah, when I do it next, go ahead and join live, and we'll maybe it's going to be even better. All right, so let's see, because we have two more questions here. Would API discoverability be useful for testing? So that's a great question, because the way I see testing is tests, and more specifically live tests, are the first client of your API. Tests are the first client. So if your API is easy to use, easy to consume, tests are going to be kind of the first ones that are going to benefit from that. So yes, it definitely does benefit from it. And if it's not easy to use, if it's not easy to consume, well, you're going to see that when you're writing the tests. Because if you're writing a slightly more complex scenario, and you can see that you're interacting with the API in an awkward manner, that's a good smell. That's a good indication that you need to improve the design. So yeah, tests are definitely a big jump, a big thing that's going to benefit. And also after, so after answering Zen's question, let me go over a quick example. I mentioned it at the very beginning, and I said if we have time at the end, and yeah, we have a few minutes. I mean, we can definitely go over it. I just want to get a drink of water beforehand. But yeah, let's go over this question. So, have you found many real-world projects looking to implement HATEOAS? I found that in the project I've been involved in, there wasn't any requirement to add this in general. So you're definitely right, and you're definitely very close to the market. What that means is that, no, unfortunately, most APIs out there do not implement HATEOAS, or at least don't do it all the way. Now, that's also a problem with the fact that, as I was saying in the beginning, there's a lack of standardization, and there's work done here, but it's still early on. However, no, that's why I'm talking about client engagements, where I'm coming in and actually migrating stuff, or adding operations, or adding HATEOAS. That's why I'm doing that, because I'm doing that on implementations that have no HATEOAS capabilities whatsoever. I am seeing slightly HATEOAS enabled APIs as well, just not a lot of them. And that's a good indication of the fact that you cannot actually go fully HATEOAS. You cannot actually go without any documentation. I certainly don't recommend that. What I recommend is sprinkling in HATEOAS with your API, building that into your API, but not relying on it. And the reason I'm saying not relying on it is that HATEOAS can make things a lot better, but if a client maybe does not want to support the HATEOAS part, that's fine. They can go to the documentation and they can still consume your API. And actually, this ties really well into what I was wanting to mention in terms of like an example. So for example, in some client implementations, what we did was we defined a set of links, a set of URIs that are, they're called cool URIs, cool URLs. Cool URLs means they won't ever change, right? These are fixed URLs, right? And we also defined another set of secondary URLs that are flexible. And that means that the API doesn't guarantee that they won't change. So these are discoverable, right? These need to be discovered. And what that gives us is it gives us an intermediary step, but instead of full HATEOAS, it gives us like the next best thing. So not all URLs are HATEOAS enabled and flexible and can change, but some of them are. So what that means is that if, for example, and that's what we did in that implementation, we said top level URLs are fixed. You can bookmark them, you can go straight to them, they're fixed. However, secondary URLs, these need to be discovered. So they need to be discovered through the top level URL. So what that meant is that we made those discoverable with one single link. So what that means is that the client doesn't need to go through a few steps. They can get them through one single step. All of the links are at the root level of that main URL. And all of a sudden, the API doesn't guarantee that those won't change. It does guarantee that the main ones don't change, but it doesn't guarantee that the secondary ones don't change. So what that enabled us was, of course, to change those secondary URLs and to make the clients discover them. And the clients basically, well, the clients essentially always were going through a discovery process if the URL has changed. Now, these were internal clients, so we were a little bit more spoiled because we could do that. But still, we had internal clients that were developed by other teams that had nothing to do with the API team. And yeah, that was the assumption. The assumption was that we are not guaranteeing that these secondary URLs won't change. They can change and they will change. So we had this discovery process at the bootstrapping of the client that essentially the client was going through if the thing had changed. We were using caching to make sure that the client knows when the API structure and when the URI structure has changed, and that worked perfectly fine for a lot of clients that were built on top of those APIs. So different teams, different, again, internal teams, so still, better communication and things like that, but still different teams, different developers, and HATEOAS was kind of midway through. Not full HATEOAS, but almost full HATEOAS. All right. So that was my my quick story that I wanted to share at the beginning, but now that is, let me see. Okay, so we don't have any new questions, which again, if you have additional questions, feel free to ping me. Email is probably the best way to do it, but yeah, Twitter is okay as well. All right, guys. Well, thanks for attending live. Thanks for sticking with me through the whole thing. Now I'm going to probably go and drink something hot. All right. Cheers, guys, and see you next time.